Decent. All right, guys, so when you see this symbol, what is it asking you? Yeah, so each of you need to be able to figure out for yourselves, how do you say this in English? Because all math is taking English sentences and making them very, very condensed. That's really what math is learning all these symbols and what they mean in English. So a couple of ways to say this, they're really the same thing. How many 4s does it take to multiply to become 64? Or what power does 4 need on it to become 64? Right? So it needs a third power. So you can say this, this is true because what? 4 to the third equals 64. So the output to a log question is an what? Or a, depending on which word you want to use. The output to a log question is a power or an exponent. I love it. Because what is a log the inverse of? So like log base 4, here's something interesting. What's log base 4 the inverse of? You ready for it? Here it is. Log base 4 of x is the inverse of 4 to the x. Bless you.
Thank you.
So here, I really want this to make sense. How do you find inverses in almost any way I can give you the question? How do you find the inverse of a function if I give it to you graphically or algebraically? Switch x and y. X is related to domain, y is related to range, right? Okay, I like it. So, if you think about the input to this is a what? If I put a 3 in, where does it go? Up in the power. And the output of this is a power because they're inverses. One guy's input is the other guy's output. Okay. So these log problems aren't on the surface difficult once you figure out what the sentence is related to this symbol. So, for another example, what's log base 7 of 49? 2, because 7 squared is 49. I like it. What's log base 7 of 1?
7. 0.
Careful.
0.
0. Because 7 to the 0 is 1. What's log base 7 of 1/7?
1 over -1.
Yeah, you got to think again, guys, especially because we're brand new to logarithms. You've got to say to yourself, what do I raise 7 to? What power do I take 7 to get 1/7? -1. So it's not as immediate. If I say, what's the square root of 16? Without even thinking, you guys say 4. And I don't blame you. You kind of memorized that to a point where you forgot that the symbol is something itself to worry about. You know square root of 16 is 4. Why would you think? But if I gave you a problem like, let's see. What's the square root of, what you got, Jeff? I don't know, Jeff. 169. You might have to think for a minute, because this is something that we normally don't have memorized. Does anybody happen to know what that is? Well, what are you thinking? If I gave you a calculator, what would you try to do? What would you try to do to figure this out? Fantastic. Mark was like, let's try to up the game. All right. What would you try to do to figure this out? Besides use a square root symbol. You would take 12 times 12 is 144. Then you check out what's 13 times 13. Yeah, so you take a number times itself, because that's what the question is. What does it take, what does it take 2 of to multiply to be 169? So that's how you have to start to try to attack it if it's not something you already have memorized. So what about these things? You don't have any of these damn things memorized. Most of us, maybe some of you guys do. So you got to think every time you get a problem. You got to take a second and think, what power do I put on the base to make this happen? What power do I put on the base to make this happen? I like it. So what about, let's try another series here. What about log base 27 of 3? Don't say anything out loud for a second. Give people a chance to think. In fact, don't say anything out loud until I ask you to. Try to come up with an answer to this. Now, did I ask you to? Did I ask you to? Don't say anything out loud until I ask you to. I love you guys. I like the excitement. I like that. Just hold on. So what are you asking yourself? Yeah, what power do I raise 27 to get 3? No negative. What do you do to 27 multiplicatively? Like don't say I subtract 24. No, it's not what this is about. What do you do to 27? Is there a root you take? Yes, sir. I don't multiply by 1/3. That'd be 9. That would be multiplied by 3. It's a root. You're not thinking about multiply by 1/3. You're thinking about raise it to the 1/3 power. So, guys, roots could be an answer to this question because roots are powers, right? The square root is 1/2 power, cube root is a 1/3 power. And logs are all about powers. So then you can think about, well, if I got to take a certain root of it, it's going to be a fractional answer. It's going to be a fractional power. So this is going to be 1/3. Because 27 to the 1/3 is 3. All right, here's a little more difficult problem. All right, what about log base 16 of 8? Again, don't say anything out loud until I ask you to. Well, there's one semester I had to stand next to somebody because no matter what I said, he would just be like, I'd stand. Don't say it out loud. All right. So I want you guys to realize something. What's log base 16 of 16? 1. What's log base 16 of 1? 0. 16 to the 0 power to 1. Now, guys, pay attention. So you guys see how in between 16 and 1, the answers have to be between 1 and 0, don't they? You guys see, if I say log base 16 of 15, that would be a number a little less than 1. I couldn't figure that out by hand because it's not really nicely related to 16. 8 is nicely related to 16, not because 8 goes into 16, but because the parts of 8 are also parts of 16. That's what's telling me it's some kind of a root. Now, how are you guys trying to attack this? Don't just tell me the answer. Is anyone actually trying to attack this thing? Yes, sir.
I'm just bringing it down to a number that can...
Yeah, good.
Do that.
So 16 is based on what number? 2. And 8 is based on 2. I like it. So tell me this. How do I make 16 become 2? What root do I have to take of it?
Or no.
4th root. Why do I take a 4th root to 16 to make it become 2? Because it takes 4 2s to multiply to 16. So if I take a 4th root of 16, I get 2. Now how many of those do I need to make 8? I got to raise that to the 3rd power. So that's that. Let me give you another way to do that kind of problem. I know the answer is going to be I love you guys. You give up the minute you see something hard. Stop doing that shit. Let yourself take it in. If the thing on the inside is in between that and 1, so that's 8 is in between those two, the answer is going to be some kind of a fraction, which to us means roots. It doesn't have to be a simple 1/4, like a fourth root. It could also involve a power, like we just saw right there. Here's another kind of way to attack this problem. If you have this problem, what's the answer? I don't know. How can I rewrite this? 16 to the x equals 8, right? Stay with me now. I'm getting a little ahead of myself, and I really don't care. I want to show you guys another kind of way to think of this. It's really related to what Avar said. 16 is 2 to the 4th. 8 is 2 to the 3rd. Stay with me. Really stay with me. This is not just for right now. This is actually going to become something everybody must be able to do this eventually. Right now, it's an option. What do I do with these? So pretty cool. This 16 is 2 to the 4th, right? So anywhere I see 16 in the universe, I can replace it with 2 to the 4th, especially when it's helpful. What do I do with these? Multiply them. So I get 2 to the 4x equals 2 cubed. What's the only way that could possibly be true is if 4x is 3. You can see that. This is saying 2 to some unknown power is 2 to the 3rd. Well, then the unknown thing's got to be freaking 3. That's the only way that's true. So that means 4x is 3. How do I solve that?
X equals
3 over freaking 4. The same answer we got, of course. Right? There's a little more, that's a little more put your teeth into it approach. Something you can really kind of like work at. This way was just sort of like, I call it building the answer. Tear this down and then build it back up. Okay, maybe. I really want you guys to get beyond just these. This should now be, if you look back at this, you're like, oh, I remember those minutes. That was so nice. Now you look back at these like, that shit's easy. Give me some of that shit, Jeff. Squaring things? Oh, hell yes. But then when the inside is in between the base and 1, the answer is going to be a root. The answer is going to be a fraction. Because it's got to be between 1 and 0. So I got to think about roots then. So for another example, what about, what you got, Jeff? I don't know, man. I got to make these up on the fly. Yeah, you do. All right. Scheisse. What about log base 27 of 81? It's a little bit different, but this is kind of another build problem. What number are these both based on? 3. What do I do to 27 to make it just become 3? I take a cube root. You guys see it? If I write this, isn't that the cube root of 27 so far? There's a 1 up top. That's the cube root of 27 because a cube root is a 1/3 power. And the thing I put over here is the power. Now what do I do to 3 to make it become 81? How many 3's make 81? 4. So the answer is 4/3. And again, let's try it the other way real quick. I don't know what it is, so I put an X there. All right, this is an alternate way to do this. Here's the first way, here's the second way. So 27 to the x equals 81. Again, I do the same idea. This is why the math doesn't care, because they're both thinking about what are they built on. 27 is built on 3 to the 3rd. 81 is built on 3 to the 4th. So it's really the same thing we did here, just totally putting it in your face, what's going on. So here I get that 3x has to equal 4 in order for that to be true. So therefore x has to be 4/3. Same answer we got up there for the same reason, really. What I'm really get you guys to understand, I want you to understand some generalizations about logarithms, but also the fact that they're always a power. So that informs you as to how to think about the problem.
I have a new method.
Sweet.
For example, 3 to the 3rd and then you put down 81 and 3 to the 4th. And then the 4th power, you bring that over and it's 4/3.
Oh, okay. It's the same kind of thing as this, but it's, you kind of made it your own thing. I love it. Nothing wrong with that. Kick ass.
And it's shorter.
Sweet. I like it. Trust me. I can show you some shortcuts. But all right. So what about, let me give you one last one of these. What about, all right, let me do this to you. Log base. Do this built off of this so it's not too evil. What about if I turn that around? Log base 81 to 27. Yeah, let me write that again. I kind of lost. There we go. Log base 81 to 27. You guys attack that any which way you want to. Just don't say the answer yet. And you say, I choose to not attack this problem. It did nothing to me. Well, that doesn't help. So if we do it this way, 81 to the x equals 27. So that's still based on 3. And now 4x has to equal 3, right? So x is 3/4. Notice how when I turn them around, the answer turns it on. Does that always work? Let's see. Let's see if that always works. Maybe that's just the only problem that works for you. You guys see that? That was 4/3. I flipped them around. Now it's 3/4. So let's see. What's log base 2 of 8? 3. Why 3? 2 to the 3rd is 8. I like it. So what's log base 8 of 2? Well, what do I do to 8 to make it become 2? I take a cube root. That would be, it did, look, it flipped. Intriguing. Okay. So let's look at this one I gave you guys just now. By the way, the handout for the lab tomorrow and Monday is going to be specifically about logarithms. So if you're still kind of shaky with it, which I expect you probably might be, we're going to get a little deeper into it in the lab tomorrow and the next. Okay. So here's the one I just gave you guys today. So if you still need this, you might want to come up and grab it.
Thank you.
Sure.
Is it just going to?
No. Sorry. That's going to be in the lab. All right, guys, let's try this one out here. Here's the rule we've used a few times already. And this is just that idea that a to the y equals x, so that's the other way to write it. So how do I rewrite this guy here in exponential form? 3 to the 4th equals x. And what's 3 to the 4th? 81. So just by rewriting the problem in another form, I can actually answer the question. So you guys try the next two here. Try these two. I like problem 3 because it takes you back to earlier skills. So here, how do I rewrite this? Yeah, x cubed is 125. Now, when I'm talking about logarithms, the beautiful thing is their base for us has to be real. Some of you out there might be going, well, I remember that problem, that little tricky shit, we had to subtract and do the big guy, little guy. We don't have to do that here because the base must be real for us. And when you get much further in math, you start doing some weird shit with the base. But right now, the base is real. The base actually for us has to be bigger than 0. So here, what do you get for the real answer? 5. Now this one, you rewrite it, and you got a little bit of work to do. You rewrite this, you get 32 to the 2/5 is x. Now, how do I attack this? What's the 2/5 power mean? What's the 5 mean? 5th root of 32. Don't put the square on the inside. Don't be crazy. And then put like question mark. How can you expect me to do this, Jeff? Square on the outside, shit. 5th root of 32. Yeah, some of you guys might be scared that you know that right after that. 2 to the 4th is 16, times another 2 is 32. So that's 2 squared is 4. Crazy. Sweet. I like it. Okay. Oh, good. All right. Yeah, we're time for this. So again, there will be a worksheet we'll be working on lab on Thursday and Monday that goes a decent amount deeper into the idea behind the logarithms. Okay, so if you'd like to understand this stuff, you might not want to miss those ones. Any last? So logarithms, we live in California, so I didn't used to live in California. You live in Virginia, so we didn't really have to worry about certain things like earthquakes. And normally we got hurricanes, so flooding, we got too much rain. So that's completely turned around for me now. I got fires, and I've only felt, knock on wood, I'm not asking for it, but I've only felt one earthquake. And I thought somebody just dropped something really big on the roof of my apartment building. That's what it felt like. Anyway, you guys know how Richter scale works for earthquakes? You think you do, right? It's a logarithmic scale, which means that every increase by 1 is actually a factor of 10. It's a log base 10. So they're used to measure earthquake magnitude. They're used to measure sound volume. I'm sure you guys have all heard decibels. You know the comparison between a jackhammer versus a rock concert or something. And the acidity of liquids in chemistry. You use logarithms to measure that. Okay. So, I mean, those are some places that we actually use these logs in real life. Since our number system is based on 10, the most common log to use is base 10, and so we call it the common log. It's actually silly. So like the square root. The square root is the most used root. So do we even put a 2 in it? No, we just go, if it doesn't have anything, then we know it's 2. So log base 10, we don't even put the 10. We just put log. So if you look at your calculator and you see a log button, that's what it means, log base 10. I don't have to write the base because it's just the freaking one that we use the most. Just like square root. So here, I promised you that the properties of logarithms are the same as the properties of powers. Yes, sir?
Oh, I know about decibels. Because that is an average that they use to measure my hearing loss.
Well, there you go. Yeah, exactly. So there's a certain range that most humans can hear. What's really weird is, I remember my physics teacher turned the frequency of sound so far up that we couldn't hear it anymore. So it's like a dog whistle or something. But the minute he adjusted it, we heard it for a second, because the human ear is really good at changes, even if it's beyond the normal hearing range. Anyway, just a little aside note. So I like that. Let's see. So right here. Now let me try to break these things down, and I'll give some concrete examples of these. Because on the surface, this looks like a bunch of, So now watch this. What's the base on everything in this? What's the base in that whole statement, this first statement here? A is the base. And what does a log represent? Always. What's the answer to a log represent? The power. So when I multiply two things that have the same base, that's what that says. They both have a base of A, don't they? When I multiply two things that have the same base, what do I do with their powers? Add them. There. When I multiply things with the same base, I add the powers. That's all that's saying. So for example, if I have log base A of 3 times 3 squared. So let's do this directly. What is 3 times 3 squared? Not A, Jeff. Log base 3. Log base 3 of 3 times 3 squared. What is 3 times 3 squared?
3 power 3.
Sure. And what's the answer? 3. Now what do I get if I break them up? Here's what people really freak out about, especially because I often say multiplication cannot become addition. That is not what's happening here. This is saying that the log of a product becomes the sum of the logs. That's what this says. The log of a product becomes the sum of the logs. Nowhere am I adding m and n. So m times n did not become m plus n. The log of n times n becomes a log of m plus the log of n. So here, what would this be officially? This would be log base 3 of 3 plus log base 3 of 3 squared. Well, what's log base 3 of 3? 1. What's log base 3 of 3 squared? 2. And 1 plus 2 is 3. The same thing. So, I mean, that's all that property is showing. Is that the power on the product of things with like bases is the sum of the powers on each. We already knew that. It's the property of powers. Yes? Oh, you're good. Stretch. Here, not surprisingly, same idea, right? What do I do with the powers when I divide? Subtract, right? That captures that same power property we knew already. And finally, this guy is also a property. What do I do with something that's raised to a power raised to another power? What do I do with the two powers? Multiply them. So this is something with a power raised to another power. I multiply the two powers. The p power and the log am. That's a power. I multiply the two powers. Let me prove that last one a different way. Because I know you all want me to. No, too bad. I'm going to do it here. So let's say I have, Let's break this sucker down. Let's use this first property on this. How am I going to use the first property on this? Well, the fact that, what does this mean? What does m to the p mean? What does that mean? What does m to the p power mean? What does m cubed mean? What does m cubed mean? Yes, it means m times m times m. I love it. I know some of you guys are like, well, I know that. I didn't know what you were asking for. So that's what m cubed means, is m 3 times multiplied, right? All right. So what does m to the p mean? M multiplied by itself p times, right? So this would be log base a of m times m times m da 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 times m p times. Whoop. Stay with me now. What's the property? What's the first property say that I do with a product? I break it up into the sum of the logs, right? So this would be log base a of m plus log base a of m, keep going, plus log base a of m. How many times? P times. You have a good time? Good time? Yeah, P times. So, if I add the same thing, P times, how can I write that better? So like, if I added these three, what's a better way to write that? This plus itself is, what's x plus x plus x?
X over 3.
What's x plus x plus x?
3x.
3x. Okay. So what's log am? Log am, log am? 3 log am. But now how many do I actually have? P of them. So this will be P log am. So log base A of m to the P. What's it look like the P just does? What's it look like the P just does? It looks like the P just falls out here and makes a plug, right? But we see why the property is true, but can you see a shortcut now? Whatever the power is up here, comes out for us. Let's try a concrete example. Log base 4 of 4 cubed. What would that be, of course? It should be 3, right? So see, if I use this property, the 3 just comes out. What is log base 4 of 4? 1, 3. This actually comes out to be the most important property of logarithms. We'll see that when we get to solving equations. This is the property that allows me to solve weird little equations with exponentials in them. Okay. So, like anything, this takes practice to get used to. I really, really want you guys. So, look here. What property of powers is this related to? I'm multiplying two things with the same base, so I'm going to do what with them? What were the powers? Add the powers. So it's this power, the power on the 7 piece, plus the power on the x piece. Bless you. So it's a really nice way to memorize these. Yes, you need to memorize these rules of logarithms because you've already memorized them. They're the rules of powers. You guys do this one. Yes. Do you have the answer? Okay, I think we're ready, maybe. What would this be?
Log A plus log A over C plus log A.
I like it. So students sometimes get a little too excited over this because it is relatively easy, even though you don't understand fully why it's true. I don't completely blame you. If I showed you a true proof of this, and what I did earlier was not a true proof of this, it would be really, really hard to follow, but sometimes I try. So let's see, maybe I will eventually. All this is saying is that whatever power A needs on it to become these, I would add each one individually to get it. Because when I multiply things with like bases, I add the powers. That's all it's saying. A log is a power, so that's why they have the same properties. What about this guy? This is going backwards now. I'm adding them, so I must have been doing what to the things on the inside? I must have been multiplying them. When do I add powers? When I was multiplying the stuff. This actually seems like a very good way. This is the way normally we would do in mathematics. Is math, we're always trying to get things together. Almost always. What's the base here? What's the base? 10. Is there a base that you can see? No. So it's sort of like, if you see this, what's the root? Third root, right? If you see this, what's the root? Second root. I don't see a 2. And you're like, well, no, of course not. Okay, I don't see any freaking base, but that tells me it's base 10. Because it's the most commonly used logarithm, because our number system is based on 10. Do I need to know that to do this problem? No. But still. So how do I rewrite this?
Log x squared.
Yeah, log x squared minus 3x. So just multiply these two things together inside. Because I'm adding powers, so I must have been multiplying the stuff. And here's the same kind of idea, just with the quotient rule instead. So this guy can actually do a little bit more with this. How would I write this? So I'm dividing, so what am I going to do with the powers? Subtract, so we log 521. That's the power on that piece, minus power on this piece. Yeah, log 521. I can't do anything with that. This is sort of like roots. Like I leave the one I can't do anything with, and I try to do something with the one I can. And of course, what's this? What's log base 5 of 25? 2. I always get somebody tell me it's 5. Like, why would we create a log symbol for division? I already have a division symbol. So this can't be just division. It takes 2 5s to multiply by 25. That's why it's 2. Please, dear God, don't make this log 519. These are not like terms, right? What about this guy here? Yeah, it'd be log A S minus log base T. Log AT. Log S minus log T. I'm not going to try to squeeze that in today. One last one will do. These couple. This is the same one as the reverse side. I'm just going to use that property in reverse. Math can go both ways. Yeah, this would be log 8, 10 over 2. I'm subtracting power, so I must have been dividing this stuff. So it's log base 8 of 5. Cool. And then this guy would just be log base 2 of minus 1. I lied a second ago. One last thing. Ha! Jeff, you're so good. Watch this, real quick. Remember log base 8? In fact, let's do something more. Log base 2 of 1/8. Let's break that down a different way. Let's use the power rule we just figured out. This would be log base 2 of 1 minus log base 2 of 8. Is that, do you guys see that? When I divide things, I must have been subtracting the powers. What's log base 2 of 1? Yes, 2 needs a 0 power on it to become 1. What's log base 2 of 8? How many 2's to make 8? 3. So then that's negative 3. And that's exactly right. 2 cubed is 8. To flip it, it needs a negative on it. Bam! You can use the properties to help you do these if you have any trouble with these. That's crazy. Okay, that's enough. Beating you over the head with logs. I'll see some of you guys in the lab. We're going to do a little worksheet